This is TCI Ed Puzzle, Lesson 4, Section 1, and it talks about the motion of particles. We should be able to answer, how do atoms and molecules move in solids, liquids, and gases? A cold lump that looks like ordinary ice sinks to the bottom of a clear liquid. Bubbles of a smoky vapor gurgle to the top as if the mixture is boiling. Yet, the liquid is about the same temperature as the room. Something must be different. As the bubbles burst to the surface, the vapor pours down the sides of the beaker. You can tell that this is no ordinary gas because it sinks in the surrounding air and clings to the tabletop like a heavy fog. What is going on here? The solid material is actually dry ice. Dry ice looks like the ice that you might get from your freezer, but it acts nothing like it. It sinks in water instead of floating at the water's surface. It also seems to boil instead of melt when placed in cool water. That's because dry ice is not frozen water. It is frozen carbon dioxide. Water and carbon dioxide are different substances, so they can take different forms at the same temperature. At room temperature, carbon dioxide is a gas. When the dry ice warmed up, the carbon dioxide formed bubbles of gas that floated up. In the previous lessons, you learned that different substances have different properties. In this lesson, you will learn what causes the same substance to have different properties under different conditions. You will learn how the behavior of particles explains their macroscopic appearance. Remember, macroscopic is the appearance that you can see without any aid of a microscope or anything like that. Additionally, you will learn how the temperature and pressure of a substance determine the substance properties. Recognizing the relationship between temperature and pressure and a substance state of matter allow you to predict how a substance will behave in different situations. This is section 1, page 56, molecular motion in solids. Dry ice and ordinary ice behave differently when dropped into liquid water because they're different substances. Yet, when cold, both look like blocks that have a rigid shape. Why do they look so similar when they are different substances? Dry ice and ordinary ice have similarities because they exist as the same state of matter. A state of matter is the physical form matter takes on as determined by the arrangement and motion of its atoms or molecules. The three most common states of matter on Earth are solid, liquid, and gas. There are other states of matter, but you are probably less familiar with them. This picture, figure 1, shows the molecules that make up a solid. Like ice, they're closely packed together and can only vibrate within their fixed positions, so they don't move very much. This arrangement of the molecules and their limited motion are reflected in a solid's macroscopic behavior. So because they're so rigid and packed together and don't move very much, we see that as a solid. Dry ice and ice are made from water, and dry ice and ice made from water are both solids. In a solid, the atoms or molecules are closely packed and touching one another, and they are unable to move around within the solid. They can only vibrate in place. Since the particles in a solid are closely packed and touching one another, a macroscopic amount of solid is considered to have a fixed shape and volume. Suppose you had a wooden cube with sides that are each 1 centimeter in length. The volume of the cube is 1 cubic centimeter. That volume does not change whether you keep the cube in your pocket, roll it onto a table, or drop it into a cup. The wooden cube does not get bigger or smaller, and the cube shape does not change because the particles of matter within the wood remain in fixed positions, closely packed and touching each other. The same is true of ordinary ice and dry ice because they are also substances in their solid forms. An ice cube has a fixed volume because the water molecules within it cannot spread any further apart or come any closer together, and because its water molecules cannot slide past one another or rearrange their positions, an ice cube has a fixed shape. The properties of the solid reflect the arrangement and motion of its molecules.